give you some examples of how we can use some machine learning techniques, which are actually using these fairness definitions to clear data, to clear the algorithm that we are using, or to clear the outcome. The first, I will talk about the pre-processing step, so how we can clear the data if we know, for example, the data is not fair. How we know the data is not fair? Through the fairness metrics that we are using. One thing that we should remember is that the bias in data is very different than the quality of the data. Quality of the data could be low because of the noise, because of, like, for example, we have different representations of the population in data. But it doesn't necessarily mean that the data has bias. So we have to keep in mind that these two terms are very different. Although the bias is coming from the low-quality data, it could also increase discrimination. So where the data bias coming from? So there is a very nice paper by Emre Kissiman, Fernando Diaz, and Alexander Oltiano. And they're talking about different types of biases which is coming from the data. The examples that I will give you now is coming from social media, but it's not just social media. So we have population bias, behavior bias, content production bias, linking bias, and temporal bias. What is population bias is that we could have a system that different population actually use it differently. So if you, for example, looking at Facebook, the users are mostly female. If you're looking at Twitter, it's vice versa. So we have more male population using Twitter than female ones. Also, for example, Pinterest, women are more used Pinterest than men, for instance. So we have different populations using the data. And we cannot change it because that's the extreme is coming. We could have behavior biases. So if we have different products, for example, the emoji. Emoji that, like Apple, the representation of the emoji that Apple has is different than Google, is different than LG. So here is just one example of this smiley eye. And if you look at it, it's all the presentation of the same emoji, but it's a bit happier for Google than in terms of Apple, right? And there are some very cute examples of like people actually texting each other, and because of the emojis, they have different, they get it differently. The meaning is different, because some people say it's actually happy, or it's not happy. So actually, they run the questionnaire, and they see that people actually say that this emoji, which is the same emoji, it's more neutral or even negative than these emojis from Samsung, Google. So it's actually coming, this behavior is actually there is a bias in behavior. So if you collect the data, this is one emoji, representations are different, the meaning is actually different. There's a content production bias. So, for example, the text written by men is different than women. So men, female use more emojis than men in their texts. Or they use OMG, for example, more often than men. So there is this content bias as well. So in the text itself, there is a bias. There could be also linking biases. So we have this, for example, graph in social graph. People are using it differently. So I'm using, for example, Facebook to connect to my friends. People use Facebook, for example, to exchange knowledge. There is some usage of LinkedIn for actually the same as Facebook. So people are actually using this platform differently. And the graph that they have is also different. So if we are having some, for example, product giving to people, if they are using the graph differently and they have more connections, they may receive this product more than from, for example, those that they are not using this graph the same as the other people. So they are not really connected. So this is coming from the linking bias, the graph structure. We could also have temporal bias. So for example, Facebook, they are changing the products that they have throughout time. And the data that, for example, we have from 2007 is different than the data that we have from 2017. So if we learn the model from 2007, we cannot deploy it for 2017, because actually people use it differently. The simple example is that, for example, in Twitter, you could actually write shorter text, and they actually change it. So now they can write longer text. So all the interpretation from the words that they are using is actually different. So you have to actually change the model because there is a bias in the usage of the system. But data cleaning is not everything. So here is the worst case scenario, that we have this population. We want to draw a line for the decision. But the population for the majority and minority is very different. So the line that we can get for the majority is here. For the minority is here. How we can decide which line is better? Always there is some biases. So if we have more population for a majority, it is the case that we draw the line here because it's more accurate, right? But I will give you some examples of like how we can use data cleaning techniques to resolve the issue. I will talk about 3 simple techniques here, but there are more advanced techniques. For example, the generative adversarial network, you can actually also use it for make the data clean. But I will talk about these 3 here. And these are from the paper by Sarah Hajian from 2016. So if we have a table, and then we have, for example, gender, or like another label, and we have a decision, and we want to fix it. So there is some biases. There is an unbalance in this. The first thing that we can do, or one thing that we can do, is massaging. Massaging is that, for example, this is a line, decision line, and we can actually change it. So there are more positive outcomes for favored group, less for deprived group. So let's change it. One of the positive outcomes for the favored group, we can make it negative. One of the negative one, we can make it positive. How we can do it is we can actually have the data represented in the space and see which one are closer. So here, for example, these 2 are very close. And then we can swap, like give one of them positive and one negative. I'm not in favor of this technique because there are so many problems with it, like why we should decide in this way, how we can explain like to these people why you are not getting it because you want to make it balanced, and just we learn it from a data like this is better. This is a questionable way of like cleaning data. Another way is reweighting. So we are not actually changing anything in the data, but change the weight. So we'll give higher weight to the deprived group and lower weight to the favored group, and then learn based on it. So by changing the weight, we can balance it and then learn it. Another way is sampling. So we can sample positive and negative examples uniformly or by some hypothesis from both population to have a balanced data set, and then train the model based on a balanced data set. One thing bad about sampling is that when we have the streaming data, we always need to do the sampling. Like we have to have some hypothesis how to sample the data. And if you are missing some samples, if we are changing the hypothesis at some point and we are realizing that the way that we were sampled before is not good, we have to actually change the whole system. We have to sample it again and then do it again. So sampling is just problematic because we need to actually define how to sample, and then changing the way of sampling is actually changing the whole system.